Welcome back to freehighschooleducation.com. Today we are going to do chapter 5.5 on page 186. In this chapter, we have a rule here, the trichotomy property. For all real numbers a and b, exactly one of the following three statements is true. So we have any two numbers, a and b, and the relationship between these two numbers can be any of these three relationships. A can be equal to b, or a is more than b, or a is less than b. So these are the only three relationships between two numbers. We are going to use these in our exercises when we are solving word problems. The second part of this chapter teaches you how to translate some English statements into algebraic expressions. For example, x is greater than a or x is less than a. We already know this. X is at least a. In this case, if x is at least a, then a is the lower limit for the value of x. And whatever is x is going to be more than a. So x will be more than or equal to a. Another statement given, x is at most a. Here, a is the upper limit for x. And whatever x is going to be less than a. So in this case, x is less than or equal to a. Because x can reach up to a. X is at most a. So knowing these statements, we are going to use them to solve some of the word problems. They give you some examples on page 186. Example 1, Roberto weighs no less than 125 pounds. This is the lower limit for the weight, or the lower limit for the number we are dealing with. So x is going to be more than or equal to 125. The second example, Jesse has between 20 and 30 books. That's easy to solve. If the number of books is x, then that's between 20 and 30. Example number 2, Mr. Johnson rented a car for $39 a day plus 0.20 a mile. So plus 20 cents a mile. How far can he drive in one day if he wants to spend at most $100? So this is his upper limit. Whatever he wants to spend should not be more than 100. And he's spending this money on renting the car, and that costs him $39 to take it out, and 20 cents per mile. And this is the unknown number that we do not know. How many miles he will be able to travel if he is not going to spend more than $100. And that number is x, and this is less than or equal to 100. This is his upper limit. So now if we solve this, we take 39 to the other side. And that will be 61. We divide both sides by 0.2, and we get the number of miles to be 305. So if that's his budget, he cannot travel in the car for more than 305 miles. The next example is example number 3. The sum of two consecutive positive odd integers is at most 24. So here the upper limit is 24, and we have two consecutive positive odd integers. So if the first one is x, the second one is x plus 2. And if we add these, their sum should be at most 24. So we solve this. We take the 2 to the other side and minus it, and that will be 22. Divide by 2 both sides, and we get 11. Here we have many choices for these two odd numbers. The first choice, and this is the highest choice possible, is 11. So let's see. When x is 11, the second number here would be 13. So this is the first set. And if we add them together, that will be 24. And that's the uppermost allowed value in this case. We said these, when they add up to a number of 24. So this is our first set. The second set will be a little bit less, and actually it will be 2 less for this number, and that's 9. And the second number associated with 9, since this is 9, the other number we already know it is a consecutive number. So we cannot match any two odd numbers. If this is 9, the second number will be 2 more, and that's 11. And we go all the way down to number 1. Then we have 7, and here we have 9. Then we have 5, and here we have 7, and then we have 3, and 5, and 1, and 3. So these are the values whereby they are odd numbers, and if you add these two numbers, you are going to get a sum which is less than 24. And with this, we come to the end of this session. We hope to see you again.